Now that you have Minitab open, make sure that you open up multiple_regression.mpj. It's a Minitab project, and that's where our regression data is. The first thing that you'll see when you open it up is this worksheet. You can see that we have a column for the date field, detailing, journals, mailings, meetings, prices, promotional items. I'll scroll over a little bit, Salesforce spending, and units sold. Units sold is the output characteristic, and we want to find out if any of these input X's are related to that output. And we'll start with going to the stat pull down, click on that, go down to where it says regression, and notice that we have regression, stepwise, fitted line plot. We're going to use the fitted line plot a little bit later. Now let's just go right to regression. And when the dialog box comes up, and I'll just move it to keep it in the screen here, we are going to delete what was already in there. Units sold is the Y, the response, so I'm going to click on units sold. And I'm going to put detailing all the way through Salesforce spending. Hold down the Shift key, highlight that. Now once you have a whole bunch of things highlighted, if I want to move it into my predictor box, I'm going to have to hit the select button. All right, and that puts it over there. If you were to double click, only one item would move over at a time. Now the graphs that we want to have, we want a standardized residual plot, and we are going to do the 4-in-1. So we'll get all of the plots. The thing that we're trying to do here is we want to make sure that the residuals are normally distributed and 95% of them are within plus or minus 2 standard deviations of the mean. So we're going to check that with the 4-in-1 plot. And let's see, we have options, and in this first go around I'm going to turn off the variance inflation factors. We're not going to do that, and I'm just going to say okay, we're going to get to that in a little bit. Results, we would like to display the regression equation, table of coefficients, S, R squared, and basic analysis of variance. Let's click on that and say OK. Storage, right now we're not going to be storing anything, so I'm just turning everything off. And we're going to run our very first regression model. And in multiple regression, you end up doing this multiple iterations or multiple times, because we first need to get the statistics to find which factors are significant and which ones aren't. So let's take a quick look at that. So we have our 4-in-1 plot. We can see that our data points are hugging this line, and that is a normal probability plot. It doesn't look like there's any kind of patterns or anything going on here between the fitted values and the standardized residuals. The observations in order, they're randomly going around, nothing going on there, and it does look like we've got at least 95% of the residuals within plus or minus 2 standard deviations. So that looks good. And if we want to see the regression, we need to go to the session window. So if we go up to the big blue eye and go right to the scroll, that's the session window. We can click on that, and we're going to scroll up a little bit here. And you can see that it has given us a equation. Now right now we don't want to consider that equation to be meaningful because we need to look at the t-statistics, and we can see that detailing and promotional items and mailings all have t-statistics that are less than or equal to the absolute value of 1. So their absolute value is less than or equal to 1, so that means they have p-values that are giant, which also means that they are not significant and they don't contribute to the model. So without any further ado, we are going to run the model again. So you can click on the Edit Last Dialog box, or you can press Control E. I'm just going to hit Edit Last Dialog box, and it's going to bring up our window here. And so we want to have, I'm going to delete these guys, we don't need those now. We do want to have, I'm just going to move it out of the way so we can see the statistics here. Actually, I'll put it over here. How's that sound? Next to the t-values. There we go. All right, so detailing is not one that we want to keep. Journal ads. Yep, we want to keep journals. How about mailings? No, too small. Prices? Yep. Meetings, prices. Salesforce spending? Yeah. And let's see, promotional items. No, we don't want those. So we want to have journals, meetings, prices, and Salesforce spending. All right, perfect. And let's say OK again. All right, that's going to look the same. No difference there. We're going to go to the session window again. And we can see that we now have 4 variables left in our model. And just for shucks and jollies, we're going to go ahead and run it one more time. And I should have turned this on. That's my fault. We'll just do it again real quick. And under options this time, we're going to turn on the variance inflation factors. And let's just go ahead and do it again. And this is going to still look the same. Go to the session window. So now we have the VIFs over here, and we are looking to make sure that we have VIFs that are less than or equal to 5. And in this case we have 2 VIFs, meetings and Salesforce spending, that have high variance inflation factor numbers. So we need to find out is these guys, because of the VIFs, it's saying that they're related to another one of the input variables. So an X is related to another X, and we don't want to have that. So we're going to take a look and see which of these guys is the culprit. So what's going on? So the way to do that is we can go to the graph, and we can do a matrix plot. And we are going to do just a simple one. Select a simple matrix plot. And what we want to have in our matrix plot, I'm going to delete what's in there. We want to have journals, we want to have meetings, prices, and Salesforce spending. Under matrix options, lower left and on the diagonal, that's what we want to select. And now we can just go ahead and say, okay, make this plot. So we're going to say okay. And there's our matrix plot. And when we take a look at this, do we have any relationships going on? Well, one that looks like it's pretty strong is meetings and Salesforce spending. And that does look pretty strong. Well, it's interesting because when we do the cost analysis, we find out that meetings is part of the Salesforce spending budget. So they should be related. Meetings is actually driving Salesforce spending. So we can only have one of these two in the model. So let's go back to the session window, and we're going to select the variable that has the strongest influence. So we see that meetings has a p-value of 0.019 and Salesforce spending is 0.069. So that's even greater than 0.05. We would like to have at least 95% confidence. So 1 minus the p-value is the confidence. So if the p-value is 0.05, 1 minus 0.05 is 95%. And we're going to take Salesforce spending out of the model. So to get our final model, I know it seems like we're doing this a million times, but that's multiple regression. And what we're going to do, whoops, edit last dialog box. We don't want to do that. Do stat, regression, regression, and we are taking Salesforce spending out of the model. And in the options, we don't need the VIFs anymore. Say OK. Storage, we want to store the fits. And we're going to say OK. And then say OK again. Alright, that's going to look the same, which we would expect. A little bit tighter now because we've eliminated some of the variables there. We get the whole distribution within plus or minus 2 standard deviations. So it did tighten that up a little bit. We're at 94.4% R square. We've got an overall model that p-value of 0.000. Okay, so that means that 1 minus 000 and then some number is going to be a very large confidence, so it's 99.99% plus, we can see that we have all of our factors, journals, meetings, and prices are all significant at least a 95% or greater. And so we know that we now have confidence in this equation as a predictor. So if we want to take a look at what the whole model looks like, we'll generate the graphics next. The graphics that we're going to create are going to be leverage plots. So let's take a look at our data. We've generated a column of fits, which is the mathematically created data that came from our regression equation. And that's actually a prediction. So we're going to change the name of that to prediction, and it's right next to units sold. So to make a whole model, we're going to do a leverage plot of units sold versus the prediction, so you can see what the whole model actually looks like and how good of a model it is. So to do that, we're going to go to Stat, Regression, and Fitted Line Plot, and we're going to have units sold versus our X predictor, which is the prediction. The graphs that we're going to have, standardized 4 and 1 for the residuals. Under Options, we're going to display the confidence interval, the prediction interval, at a 95% confidence level, and we'll put a title in here, Whole Model for Promotional Effectiveness. And we'll say OK. And then let's just go ahead and generate our fitted line plot for the whole model. If we take a look at the residuals, 95% of them are at least within plus or minus 2 standard deviations. It looks like they're all within plus or minus 2 standard deviations. They're hugging the line very nicely here, nice and normally distributed. There's no patterns going on in any of the data, so we can say that those are fine. If we go up to the big blue eye and left over to the Show Graphs folder, we can double click on our fitted line plot, and so here's the whole model fitted line plot. And you can see that our data fits pretty tightly to our regression line, which is the prediction line, and this is a pretty solid model. Now you can see between the green lines, that's how much variation there is in our equation's ability to predict the future. And the red lines, that's the 95% confidence interval that says with a 95% confidence, we would expect to see our regression line sitting somewhere in between these two. So it's right in the center of that. And then our ability to predict does have some variability in it. All right, and that's based on, we don't have a perfect fit. We only have a 94.4% explanation of what's going on. So there's still some unexplained variation. And we can take a look at the leverage plots that we have for the factors that are significant. So let's go back to our session window here. And you can see from the whole model that we've got a p-value of 0.000, so that's a very strong confidence at 99.99%. 94.1% of the variation is explained by our model. And if we come back up here, this is the equation that we're using to predict, and that is our whole model. It's a validated equation. Now what we want to do is take a look at some graphics that will show us how journals, meetings, or prices may influence units sold. So to do that, we're going to generate some fitted line plots. So we should be able to just pull down our Edit Last dialog box. It's going to be, the response is still units sold. Our first one is going to be journals, and we'll go to options, and we're just going to call this one journals, and we're going to make that one and say OK. And we'll take a look at all this stuff in a second here. I'm going to go, let's just make all three of these real quick, and then we'll take a look at them all. Next one is going to be meetings. So it's going to be meetings. And we'll put in a name for that one, meetings. Whoops, we're out of spell here. Meetings. Sorry about that, people. There we go, meetings. And make that one. And go back to the session window one last time. And we're scrolling up. And the last one that we're going to use is prices. Click on prices, options, and this is going to be prices. All right. So the residuals don't look too bad for units sold. Let's go to the big blue eye and we'll take a look at all of these. We have residuals for units sold for journals. And there's our journals leverage plot. So you can see that as we increase journals, we would increase our units sold. We have here's a residual plot for that. Then we have meetings. You can see that as meetings increase, we also increase units sold. Here's the residuals for that. Those look fine. And then last but not least, we have our prices. Now prices is a negative relationship, so as we increase prices, it decreases the number of units sold. And here's the residual plot for that as well. So that's how you would use those leverage plots to give you an idea of the direction you need to go in if you are going to use these three variables. So you can use this as a way to quickly, with a graphic, say we dropped our prices from here to here. What's that going to do from a standpoint of sales? We can take a look at if we increase the number of meetings, what's the impact that that potentially will have? If we are going to increase the number of journal ads we're going to place, what's that going to do to our units sold? And so the model can be used to actually make a prediction based on the changes that we're going to make in these promotional activities. So that's our multiple regression analysis. Thank you for your attention.